Hello and thanks for watching Best Maths Tutors. Currently going through the higher tier paper 3 from 2019 from Edexcel, and this is question 11, and we're going to cover all the questions. So if this is helpful to you, please click the subscribe button at the bottom. So question 11 is a question about standard form. So we can see that here we've got a number which is written in standard form. Standard form is a way of helping us write either very big or very small numbers in a manageable form. So for example, that 3.9 times 10 to the 7 is actually would be written as 39000. Let me just see, 1, 2, 3, 4, 5, 6, 7. So the 10 to the 7 has the effect of moving the decimal point from between the 3 and the 9 to the end of the number. So it's actually, this is what this number would be if we'd written it down normally. And we can see just how difficult it is to write when we've got so many zeros there. So it makes it quite difficult to write, and I'm struggling myself to just make sure I've got enough zeros there. So we've got 6 zeros at the end of this number. So this number is actually 39 million. And this shows the use of doing stuff in standard form, because we can see that we can write a number which is as big and unwieldy as this in quite a manageable form, and one which we can see immediately by the 7 there how big it is. So this question is talking about a signal being sent from Earth to Mars, and we're being told that the distance between Earth and Mars is this, which is 39 million kilometers actually. So 39 million kilometers. And it says, assuming that the signal sent from Earth to Mars travels at a speed of 3 times 10 to the 5 kilometers per second. And I'll just write down what that would be as well, just so we get an idea of what this standard form means. So that would, the way it works is the 10 to the 5 is actually is 10,000. It's 100,000, because it's a 1 with 5 zeros. So that's where the 5 comes from. So if we multiplied this out, we actually get 300,000. So we're being told that this signal can travel at 300,000 kilometers per second. And we've got to work out how long did this signal take to get to Mars. So we know from our distance, speed, time triangle, this is a good way of remembering it. So we've got distance at the top, and then we've got speed and time. So whichever one of these we want to be able to get, so if we're looking for the time, so we're looking for the time here, then what we're left with is a fraction, which is distance over speed. If we wanted to know what the distance was, actually we'd be left with, if we covered up the one we want, we'd be left with speed times time. So because we're looking for time, we've got time, so how long did the signal take to get to Mars, is equal to distance over speed. Now, in this question, we could actually just work in normal or ordinary form and convert these numbers that are in standard form into normal form and then carry on from there. But it's actually a lot easier if we can work it using the standard form that's been given, rather than having to convert into ordinary form. So this is the ordinary form here. That's ordinary or normal form. And this is standard form. So it's a lot easier if we can work in the standard form. And let me show you how we would do that. So we've got 3.9 times 10 to the 7. And what we're going to do is we're going to divide it by 3 times 10 to the 5. So what we do is we actually move the number part, which is the bit at the beginning, together, and we say we've got the 3.9 divided by 3. So bring those together. And then what we do, we need to get the bit with the power on then. And that's times, because we still want the answer in standard form. So times, and then we do 10 to the 7 divided by 10 to the 5. So we've got this number's in 2 parts. So if we divide 3.9 by 3, I'll just get my calculator up to show you this. So 3.9 divided by 3, you can see that we get 1.3. So 1.3. And then if we want to do the bit with the powers on, the 10s to the power, what we do when we're dividing something that's got a power on it, providing this number here is the same, so we've got a 10 and a 10, that's the same. And what we do, we subtract the powers. So we've got 7 take away 5 is 2. So it becomes 1.3 times 10 to the 2. And that would be fine for our answer. So 1.3 times 10 to the 2 seconds would be our answer there. If we did want to convert it into ordinary form, it doesn't tell us that we've got to, but just to demonstrate what we would do, we would take the decimal point, and whatever number is here, it's the 2. So we can write the 1.3. I'm just going to write some zeros after it. And we can move the decimal point as many places to the right as it says here. If it was a negative number, we move to the left. Because it's a positive number, positive 2, we move to the right. So we skip over 1, 2 places, and we can see that in ordinary form, that's where the decimal point would go. So it's actually 130. So it's telling us it takes 130 seconds if we was to write it in ordinary form, but in standard form, it's fine to give the answer like that as well. And it's 1.3 times 10 to the power 2 seconds. So that's part A done. And now if we look at part B, it says the speed of the signal was actually less than the speed given. So it's less than the 3 times 10 to the 5. So how does this affect the answer to part A? Well, we've got time, again, from this triangle here. We've got time is equal to distance over speed. Now, if the speed of the signal is actually less, so if the speed reduces, then if we make the bottom part of the fraction, so if we make the speed lower, so this becomes lower, then the overall value of the fraction becomes bigger. So what that's going to mean is it will take longer because the time will be bigger. So our answer would be it will actually take longer. It will take longer. And that makes sense anyway, because we can see that if we went somewhere at a slower speed, obviously it would take us longer to get there. So that's our answer. So I hope that's helpful, and if it is, please like our video and subscribe to our channel to see more of our videos, and also visit our website bestmathstutors.co.uk for more help. Thanks for watching.